What if your diet endangered your great-grandchildren? Studies show that the negative impact on the heart of obesity and diabetes can still be present after several generations. Our lifestyle, diet, physical activity, etc., has consequences for our health, and that of our descendant. An American study showed in mice that heart problems caused by obesity were found in the offspring of obese parents for at least 3 generations, even if the new generations were not themselves overweight. We already knew that a diet that was too fatty and too sweet had a negative impact on the heart, but now we have seen that these consequences are more serious in the offspring than in the parents who consumed this diet, explains researcher Kelle. Moley, reproductive health specialist at Washington University in St. Louis, U.S. In this research, published in the scientific journal American Journal of Physiology in March 2019, mice were made obese on a diet high in fat and sugar. This resulted in heart defects in their offspring, while the parents did not have these deficiencies. Even more surprisingly, these heart failures were present up to 3 generations later, even if the new generations ate a normal diet and were not obese. Energy defects at the origin of cardiac deficiency. In a previous study, published in the journal Cell in 2016, Moley and his team found that obesity caused defects in mitochondria, the powerhouses of our cells, and that these defects were inherited for several generations. Affected mitochondria could not produce enough energy to fuel the heart, leading to heart failure. We thought that these heart defects were due to changes in mitochondrial DNA, which is different from so-called nuclear DNA, the one located at the heart of our cells in the chromosome. However, this mitochondrial DNA has the particularity of being transmitted only by the moth. But in this new study we have seen that the father can also transmit these metabolic defects, is surprised Kelle. They are therefore, not only caused by mitochondrial DNA but also by nuclear DNA, which is important for mitochondrial function and which can be transmitted from the father. Epigenetic transmission? However, these would not be modifications directly to the genes, or genetic mutations, but to elements that regulate their expressio. Obesity and diabetes alter the epigenome, that is to say all the modifications made to the genome to adapt its expression to the environmental context, explains Valerie Grandjean, specialist in genetic expression at the University of Nick. To express itself, a gene is in fact first transcribed into RNA, a sort of mobile version of itself which will transmit its orders to make protein. The epigenome modifies this mechanism, without the gene itself being altered. These epigenetic elements can be found in the germ cells, oocytes and spermatozoa, of the parents, and thus pass on to the next generation, reveals Valerie Grandjean. This is how the changes caused by obesity in the functioning of the mitochondria would pass on to subsequent generation. But the epigenome is constantly adapting to our environment, including our diet. So why do these epigenetic changes persist after several generations, despite returning to a normal diet? Researcher Valerie Grandjean and Bernard Portha, pancreas specialist at the University of Paris Diderot, have made an inventory of the scientific data available on this subject. In a review published in January 2019 in the journal Nutrient, several studies show this type of transgenerational transmission, but the exact mechanism is not yet known, recognizes Bernard Portha. What this work shows is that obesity in our ancestors is a risk factor to be taken into account. But it is not irreversible. With a healthy lifestyle we can compensate for this bad heritage, concludes Valerie Grandjean.